Hello everybody. Our class today is about using HAP software. HAP software is a program that used to estimating cooling and heating load. It stands for hourly analysis process, or sorry, an hourly analysis program. This example will be brief and giving, I hope, very good introduction to using this software to estimate spaces cooling load. However, I never recommending students to start using this program unless they have idea about the principles of cooling and heating load calculations. In other words, you cannot use any software unless you have the principles for the equations, for the methodology that used in this program. Therefore, you will be able to predict or to expect the results, to check if these results make sense or not. Moreover, I'm recommending you to use space or example with definite results. So you will be able to check your solution, your findings. Are they correct or not? As they say for software, garbage in, garbage out. You have to be very careful of your inputs, because whatever you enters to this software, you will get results maybe not accurate, maybe not real, maybe doesn't make any sense. Now, I will walking you through this program step by step to estimate cooling load and heating load for a space. Our example today, it's picking one of these spaces for this building and calculate or estimate the cooling load. What do you need to know before starting the program? You need to know the dimensions of a space you are going to estimate the cooling load for. For our example, we will consider or we will estimate the cooling and heating load for guest room, this room. You need to know the U value. You need to know the structure of the building. Is built by brick, other materials, what materials, block, hollow block, concrete, what type, what types of materials that the building constructed of. You need to know that. For our example, it's built of common brick. Thickness is 25 centimeter, about 25 centimeter. U value for wall is 1.8 watt per square meter degree centigrade. U for roof, it's the roof is constructed of concrete, 0.6 watt per square meter degree centigrade. U for glass, you know, of course, what does mean U? U, the overall heat transfer coefficient. The overall heat transfer coefficient. U for wood, door, 0.6. Area of the window for guest room, 6.5 square meter, sorry. Area of the door, 2.5 square meter. And shading coefficient for the glass, 0.46. You need these informations, you need these dimensions, you need to know the direction. This window of guest room are facing south. The external wall is east. Other walls, the north and west are internal. We will assume this, the sleeping room, the adjacent sleeping room, adjacent kitchen are air conditioned. I mean, we will neglect them. Now come with me to the software. Starting with these elements. First, weather. You need to choose the location of your building, where it is. So the building now, let's choose building in USA. Here, choose the space. Is it in Africa, Asia, Canada, Europe, Middle East, whatever? Okay, so now it's USA. Location, which state is it? Let's choose West Virginia. For example, city, let's choose Morgantown. In case you don't have the city you are going to study, you can override it. You can override it. Okay? So if you don't have it, you can add it. Moreover, when you add any new location or new city, you have to adjust the latitude, longitude, elevation, summer design dry bulb, and summer coincidence wet bulb, all this information. Even if the city is available in this list, if it's available, you need to check the conditions, the weather conditions, are they correct or not? So I mean, you need to update. It's maybe not to up, maybe this not up to date. So check temperature dry bulb. I think it's beyond this 31.7. Design dry bulb, it's maximum dry bulb temperature. So we'll choose, let's say, 34. Wet bulb. It's the humidity in this city, which where I used to live in it, it's very high. So it's 22.2. It's okay. Let's make it 23. It's acceptable. Daily range. The daily range is the difference between the maximum and minimum dry bulb temperature. The maximum and minimum dry bulb temperature. Keep it as it. You can correct it as if you wish. The winter design dry bulb temperature. Winter design dry bulb temperature. It's about minus 15.6. By the way, this information are in degrees centigrade. You can convert them to Fahrenheit if you like. You can convert them to Fahrenheit if you like. How? From here. Go reference and switch to English. Instead of SI metric, switch to English metric. Will be, let's see, check this. All became in Fahrenheit, okay? But I'm more familiar with the degree centigrade, so I will return to SI metric. Now, this information are enough for you as a beginner. You can correct time zone if you need. If you added new design calculation, it's from January to December. Do you want to decrease these months or keep them as you wish? This information, clearness number, ground reflectance, keep them as, I mean, do not manipulate them because they are standard. So this information you need to update. Moreover, if you are students doing a project in advance, you maybe go this windows to update them. monthly maximum. These generate curves of the dry bulb, hourly, daily, monthly, wet bulb, and detailed view of temperature. I will not go through these about design solar, so I will maintain here. Here is enough for you to calculate, for us to calculate the cooling load. Hit OK. Now done with weather. Go to space. I think this space is very important. So space, new space, you need to name it guests, room. Okay, the floor area, how much the floor area? Let's say the floor area is 5 times 5.25. 5 times 5.25, it's 26.25. 26.25 square meter. This is the floor area. Ceiling height, let's say it's 2.9, let's say 3 meter. Okay, building weight, it's medium. Okay, brick, it's medium, acceptable. Now the other window is about internal. What is your internals? First one, water. As we know, the electric lights are very economic. And they not generate a lot of heat. So, I mean, let's say it's 10 watt per square meter. Fair enough. Okay, like this. The very important information or factor consider in this window is the occupancy. Occupancy is very large, considerable heat source. So people, how many people you have this? Let's say 15 maximum. Maximum 15. What type of work? It's seated at rest, office work. They got this is a guest room, so seated at rest. You can see here the sensible and latent cooling load will be different. So choose seated at rest. Do you have any miscellaneous loads like printer, like computers, like kitchen equipment? Any of these you can add them here. How many watt of heat? Be careful, this watt for heat generation, not electricity. Rate of watt. Okay, the other window is wall windows door, so we need to add the south window. South window is, check here, sorry, south wall. South wall is 5 times 3, 15. The gross 15. And the window 6.5. Okay, 6.5. So wall 15, window 1, door, does it has door? Yes, 1 door. Okay, 15. Now you need to define wall, define window, define door. Wall is from here. You can go from other way from here. Define it from spaces and define walls, roof, window, or from here. Either ways. So wall is gypsum board inside, airspace, block concrete block, face brick. You need to correct them. Inside is gypsum board. Yes, we have it. Do you have airspace? No. Remove it. Block concrete? No. We have common brick. We have common brick 203. Do you have outside, let's say it's cement? It's a plaster. So these types, this construction, the value of the U value is 1.6. Go back to your, it's 1.8, it's 1.8, 1.629. It's sort of fair. You can add more, you can manipulate. What do you do? You can correct this. It's not, I mean, everywhere you can override. It's 250 millimeter common brick. Correct here. 50 millimeter. Okay, so it's decreased now. Okay, you can decrease common brick or I mean like this. You can manipulate the dimension to meet your U value. Okay, these you can manipulate it. Outside surface color, is it light, medium, dark? It depends on the color. So if it's cement, consider it's medium. Okay, you can call it south, name it south wall. Okay, okay, saving. It's saved now. For window, define window. Window is dimension 6.5, 6.5. It was height 2 by 3.25. Sorry, height 2 with 3.25. Okay, U value here is 6.25. 6.25. It's relative to the thickness of glass. Okay, let's say cast room window. Okay, 2 meter. Okay, what we have else? Door. Gross area for the door is 2.5 and U value 0.6. It's wood. Sorry. Yeah, 2.5. 0.6. It's good insulated. Okay. Is the door has glass area? If yes, add it here. Otherwise, no. Okay. Keep in mind, this is wall gross area. The total area of wall is here. So when you add window, this will subtract it from the wall area. I hope that's clear. Other direction is the east, right? Here is east. This wall, it's 5.25 times 3. Okay, east, 5 times 0.5 times 3 is 15.75. Okay, Does it has window? No. Does it has door? No. It's just wall. Define the wall. Say okay. Yes. So we added the south wall, or you can add it as east wall. Same specifications. Okay. You can notice we didn't get U value 1.8, but if you are in the real work, you can correct these. But I'm in example. I don't want to take too much time. It will to correct that. So keep in mind you can correct these exactly to get the same U value. Correct? Okay. Now we are done with exterior or exposure walls, south and east. We don't have here anything else. Now going to roof. The area of roof, type of roof is horizontal, 26.3. Do you have skylight? No. Now you need to define your roof. Roof is roof is 0.6. It's concrete. So okay, inside steel deck. If you have deck, concrete, it's about low weight concrete, built up gypsum board from outside insulation, board insulation. See, this is okay. No. You can choose your, sorry, what kind of insulation do you have? What kind of insulation do you have? It's RSI 1.0. You need to use your actual build-up or insulation, tiles, whatever types. You can write here tiles, and you can enter the thickness, you can enter the density, you can enter the factors, coefficients. So you will able to get the exact number of or value of U, overall heat transfer coefficient overall heat transfer coefficient. Okay, so you can correct this. All of them you can override and input your correct data. I will not do that now. I don't have time for you to avoid the example to be very long and boring. Okay, so let's say okay, it's 0.56. The actual is 0.6. It's very close. Now infiltration, rate of infiltration and design heating. The rate is liter per second. It's several methods. P times 5 times 5.25. You have to review my lecture about infiltration and ventilation needed. Times 3. The volume will be about 78 cubic meter. Times 2, assuming 2 times air replacement due to air infiltration, divided by 3,600 seconds. So it will be times 1,000. It's about 43 liter per second. Let's say 43 for heating oil as well. Okay, this is infiltration. Floors. This is very important. Do we need to consider ventilation or not? I'm not gonna explain it here because we don't have time. But this infiltration, this is not under control. This is air infiltration from cracks of windows, doors, and opening, closing doors for people enter and out. So we assume that the air inside the space is replaced every 2 times every hour or each hour. From that, we calculated the rate of air infiltrated. We have 15 people times about 3 liters per second each people. So we'll need about 45 liters per second. I think the infiltration rate is enough for people to maintain fresh air inside the space. Floor, neglect the cooling and heating load from the floor because it's the down floor. We have no unconditioned space under it. Partitions, this part will neglect it because we assumed the adjacent spaces are cooled or heated. That means it's comfortable, it's air conditioned. So we neglect this. If you don't have these partitions air conditioned, you have to add them. Next example, next video, I will explain how to add them. It's not very complex, it's sort of easy. So for now, for the example, just neglect them. So the area is 0, means no ceiling partition, no wall partition. Hit OK. Okay, you have to define this, create the schedule. Just name it. It's house, living house. So it's all-time occupancy. Okay. All set. Now going to system. System is defined. It's sort of easier from the guest room. What type of system you need? You need split. Simple. Split air handling, package rooftop, package vertical unit. What type? Chiller? No chiller. Chiller is very big and it's not for one space. You need. So I will prefer split air handling unit. Single zone, CAB, single zone. Okay, system component. What do you need to calculate this information? Ventilation, air. This is sort of for researchers. This is sort of information for researchers, students. Zone component. Which zone? If we have more than space in the building, which zone you need to calculate the cooling load? So for this example, I have only guest room. Use this, add it here to design the cooling load for it. This is, don't play with it. Okay, all set. Hit say yes. We need to thermostat schedule. Also, just rename it. Guest room. Sorry. Okay, without space, should be without space. Say okay, all set. Now on the system, at guest room, right click, print view design results. Print view design results. So hit preview. Here the results. So this information about your space, cooling load, design. For example, the cooling load, total coil load, total coil load is 3.9 kilowatt. 3.9 kilowatt is about 1.1 ton of refrigeration. About 1.1 ton of refrigeration, or about 14 or 13,000 PTU hour. 13,000 PTU hour. When this cooling load, maximum cooling load occurs at September 1400. At September 1400. Same thing for the central heating coil sizing. For heating, it's 3.2 kilowatt. 3.2 kilowatt. Okay, so all this information you should be able to read them. For example, total is 3.9. The sensible coil load part is 3.3, and since maximum block 3.2, 320 liter per second. That's the fan speed, the air discharge. Okay, and all this formation, you need to design your cooling load or cooling system, cooling coil for the space. I'm sorry for any mistakes or any missing information. Maybe I will make up them in the next class, next example. I hope this helped you understanding HAP program. Thank you, and I'm open for any suggestions or comments from you to improve, to enhance these lectures. Thank you and have a nice day.